to calculate number of optically active isomers, optically inactive isomers, racemic mixtures and pair of enantiomers, we have certain formulas. So what are these formulas? If unsymmetrical molecule is present, unsymmetrical molecule means that we cannot divide the molecule into two equal halves, then the formula for optically active compounds, the formula equals to 2 to the power n, where n is number of chiral carbons, n equals to number of chiral carbons. If let's say if we have taken an example of here, we have an example where number of chiral carbon is 3, first carbon, second carbon and third carbon, both these 3 carbons are chiral carbons. So we have optically active, number of optically active compounds 2 to the power 3, that is 8. So we have in total optically active compounds 8. If somebody asks us how many pairs of enantiomers, so the number of enantiomer pair will always be half of, because we are talking about pair, so the number of enantiomer pair will be half of total optically active isomers. So it will be 8 by 2, that is 4. Somebody asks you now racemic mixtures, because one pair forms one in a racemic mixture, so total number of pairs is 4, so number of racemic mixtures we get is 4. That is how we calculate optically active, optically inactive and racemic mixture. Enantiomer pair also you can get from there, because if we have total of 8 optically active isomers, so pairs will be 4 and each pair forms one racemic mixture, so total racemic mixtures will be 4. That is how you can calculate these values. Along with that, if we have a symmetrical molecules, then you will have two conditions: either the number of chiral carbon will be odd, or the total number of carbon will be odd or even. If you have an odd number of atoms, then you have a separate formula. For even number of atoms, you have separate formula. What does symmetry means? Symmetry means that you can divide the molecule into two equal halves. For example, we have taken the molecule, this one as an example, where you can easily divide the molecule into two equal halves. You can divide this molecule into two equal halves. That means it is a symmetrical molecule. For symmetrical molecules, we have separate set of formulas, where if the number is even, number of atoms is even, you have a formula which says that number of optically active compounds equals to A, that is 2 to the power n minus 1, and number of optically inactive compounds or mesomers in an unsymmetrical molecules, the number of mesomers was 0, because symmetry is not there, so no plane of symmetry, so no mesomer. Here you have symmetry, so if you have symmetry, we do have mesomers. Alright, so here the formula for mesomers is 2 to the power n by 2 minus 1. Alright, so for optically active compounds, the formula is 2 to the power n minus 1, and for optically inactive compounds or mesomers, the formula is 2 raised to the power n by 2 minus 1. Similarly, you have formula for this one was for the molecule having divisibility into identical halves and even number of carbon atoms, and there is separate formula which is for odd number of carbon atoms. You can easily apply these formulas, and just you have to remember the counting of chiral carbon is very critical, because value of n is taken from number of chiral carbons. Here you have number of chiral carbon 1, 2, 3, 4, then you put the value in the formula and you get the answer. So you have to just remember the formulas and you will be easily calculating the values of number of optically active compounds, mesomers, racemic mixtures, enantiomers, all in the arranged manner, or I would say in a pattern. Once you remember, let's say optically active compounds, you get a formula A, so number of enantiomer pairs will be A by 2, number of racemic mixtures will be A by 2, number of mesomers and optically active compounds will be having a separate formula depending on which case we are talking about. Now we have two categories of optically active compounds. Either compound will be a dextrorotatory, that means the plane polarized light is rotating towards right, or the optically active compound will be a levorotatory, that means the plane polarized light will be getting rotated towards left. So levorotatory, plane polarized towards left, and dextrorotatory, plane polarized light towards right, and these two compounds will be called as enantiomers. If this is rotating towards right, this will rotate towards left, and they will be mirror image of each other. If it is rotating plus 30, this will rotate as minus 30. So enantiomer pair, we have a beauty that the value of rotation is same, just the direction is different. Dextrorotatory rotates plus 30, then levorotatory of the same compound will rotate towards left, the minus 30-degree rotation. So that is what dextro and levorotatory is, and how you will calculate optically active or optically inactive compounds. If you add them up, optically active plus optically inactive compound, you get total optical isomers. So that is all for now. Thank you.